Example 1 here on selecting a distribution is a practice question here in context. So what we've got here is the price of a first class plane ticket from London to Paris, and this varies according to demand. The price is symmetric about the mean of £500, it has a standard deviation of £33, and a price lower than £400 or higher than £600 is yet to be recorded. We need to suggest what distribution to use here, and then use that distribution to calculate the probability of being able to fly first class here to Paris for under £450. Well, let's jot down a few points here that will help us decide which distribution we're going to use. So the first thing we can note here is that the data is continuous. So the data is continuous. Okay, so the data is continuous. We also know, as we're told in the question here, the price is symmetric about the mean of £500. Okay, so we know it's symmetric about the mean here. So symmetric about the mean. We just jot this down as well. So symmetric about the mean here. And the other thing we can consider here is that we're told we have a standard deviation of £33. Well, we know virtually all of the data should lie between 3 standard deviations here of the mean. Well, if we times the standard deviation by 3 here, so 33 times 3, that would give us 99 here. Now, if we consider this 99 from 500 here, so if we subtract 99 from 500, that would give us 401. And if we add 99 to that, that would give us 599. And that's what we'd expect here if we're told a price lower than 400 or higher than 600 is yet to be recorded. That would suggest to us that essentially all the data lies between £401 and £599. Okay? So essentially here, all data lies between, so we just write this down in full here, 401 to 599 here, okay? And that's verified essentially by this fact here where we're told a price lower than 400 or higher than 600 is yet to be recorded. So, using these 3 points here, we can deduce that we're using a normal distribution, okay? So therefore, use a normal distribution. Okay. Now, if we're using a normal distribution, we also need to use this now to calculate this probability that we're asked to find here. Okay. So first, let's define the distribution. So if I'm going to use x here to represent this, x is a normal distribution. We have a mean of £500, and we have a standard deviation here of 33. So the variance here would be, or the variance here would be 33 squared. Okay, so that's our distribution here, and what we actually want now is the probability of being able to fly first class to Paris for under £450. So in that case here, we're looking for the probability that x is less than 450. And here we could simply work this out on our calculator here, but the probability that you should obtain here that x is less than 450 is 0.0649 there. Okay, and that gives us the solution to example 1 there. Example 2 here again is just a question in context where we need to be able to select the appropriate distribution. So here we've got a sixth form college which has a pass rate of 92%. They have 30 students taking exams this year, and they're hoping that at least 28 of these students pass. So we're asked to find the probability of this happening. Well, first here, let's decide which distribution we're using. So we note down a few points again to help us decide here. Well, the first thing we can note, in this case, the data is discrete. So the data is discrete. So the data is discrete here. And we can also see that clearly there's a fixed pass or fail probability. So there is a fixed pass / fail probability here. Okay, so jot that down in full there. And these are the only possible outcomes. The student either passes or they fail. Okay? And we'll note that these are the only possible outcomes. The only possible outcomes. Okay, so they're the only possible outcomes there. And we're also not told anything which would suggest the events of students passing may not be independent. Okay, so in that case here, using these points now, we can deduce that this is a binomial distribution. Okay, so therefore, use a binomial distribution. Okay, so here now what we want to do is just calculate this probability. So in that case, we're going to be using the binomial distribution. And first let's define the distribution here. So again, I'm going to use x to represent this. So x, in this case, is a binomial distribution. Remember, our parameters here are n and p. N represents the number of trials here. So the number of trials would be the number of students, so that would be 30. And our p is going to be the probability of passing here. So that's 92%, and as a decimal, we'd write that as 0.92. And here, what we're looking for is the probability that at least 28 of them pass. So in that case, we're looking for the probability that x is greater than or equal to 28. And in this case here, again, just simply use your calculator. And what you should get here, if you correctly calculate this probability, is 0.565 there. Okay? And that gives us the probability that at least 28 of the students pass. And that's the solution to example 2 there.